Hey guys, today we're going to talk about exponential characteristics, and so let's get started with some transformations. And so this equation at the top is just the general form of an exponential equation with some different letters going on. So the first thing we see is A, and all these letters are letters we have used and talked about before, but the transformation we're going to be using with A is if A is negative, then you have a reflection over the x-axis. Okay? B is our base. B doesn't change, and B tells us if we have an exponential growth or decay, but we're not going to include that in our transformations. That just tells you, if it's growing or getting smaller, and that'll come into account when we're talking about our increasing or decreasing. But the next thing we're going to look at is our H and K, and H and K are both letters we have seen a lot in this class, and so H is our horizontal moving, right? So H moves left to right, and it's exactly as it's been before, that it moves the opposite direction than what you think. So if it moves left, it's plus H, and if it moves right, it's minus H. Okay, and then plus K, K moves things up and down, and it's exactly as you think it would. Plus K is up, minus K is down. Okay, with domain and range, the nice thing with domain is that with exponential functions, your domain will always be negative infinity to infinity with the ones we're going to be dealing with in this class. But this is where x exists, right? Domain is always dealing with x values, and range is always dealing with y values. Okay, now your range is what can change from time to time, but what is important with your range is that you're always going to be dealing with a negative infinity, a positive infinity, and your k value. This is where you're going to see your k value show up. So you can either see negative infinity to k or k to infinity, right? And so you'll see different shapes. So negative infinity to k, would be an example of a shape like this, or a shape like this, where remember, it's always bottom to top, so the lowest that your graph gets is negative infinity, and the highest it can get is to k, because your asymptote is what's going to stop your graph, right? If we're going from k to infinity, our graph is going to start at our asymptote and go up forever, right? And so important thing with range as well is that we see parentheses here instead of brackets like we've looked at with quadratics. Because remember, with our asymptote, you never touch your asymptote, and so parentheses tell you that you can't ever touch that value, which brings us even to our equation for our asymptote, which is just y equals k, all right, which we've talked about before. Next here we have our x-intercepts and our y-intercepts, and so our x-intercept is where y is 0. And so we see this as x comma 0, and we'll see a value there where x is. And then we have our y-intercept where x is 0. And this is super easy to find in your table, which we'll look at. And so it would be 0 comma y, and you would have a value there for y. Okay? Increasing or decreasing, this is, remember when we highlight and we see, does my pencil go up or down? And so with these problems, you're just answering the question, is it increasing or decreasing? You're not saying what interval or how much it's increasing. You're just answering one or the other. So increasing graphs will look like going up like that, or let's see, if we are going like this, those are both increasing. And then then decreasing would look something, let's do pink. Decreasing would look like this, or I can never think of how I want to draw it until I get here. Oh, or like this. Those are the examples of increasing and decreasing. Because if you were to run your pencil over it, my pencil is going up for my increasing functions, and my pencil is going down from left to right on my decreasing functions. Okay, with end behavior, now I want you to pay attention to the colors I'm choosing to use here, because end behavior is going to use your domain and range every time. And so for end behavior, you're saying as x gets closer to one part of your domain, what does y do? Okay, so as x goes to negative infinity and positive infinity, those are your domain values here. Domain goes here. So if domain goes where x goes, what do you think goes with y? Well, that would be your range. So now this is your time to pick what goes in each spot here. And you have three options. You have the option of negative infinity, positive infinity, or k. Okay, you're always going to use k for one of them, but you have to choose which one. And as we do some examples, you will see what I mean by that. Okay, and so your domain, again, is always negative infinity to infinity, and then you have to choose which range goes there. Okay, let's look at this first example. With number 1, we have y equals negative 5 to the x. I also want you to notice that there are no parentheses here, and so it's not saying negative 5 to the x, it's just 5 to the x. And that negative, this right here, is our transformation of a being negative. And so this negative sign reflects over the x-axis. Okay, and then state 3 points on the graph. Well, we know how to use our table function on our calculator to find these points. So let's do that right now. So I'm going to type in this function. I'm going to go to table, right here, table, edit function, and I am typing in negative 5 raised to the x. When I type that in, I'm just going to start at 0 just to try to see what my points are here. Okay, and so when I look, I see my points. And remember, we always want to try to pick one fraction, and then we can look at the rest of our points going on here. So pick 3 points. I'm going to pick negative 1, 0, and 1 here. And so if you wanted to make a t-chart where you just have your x's and y's, and you had negative 1, 0, and 1, where I had negative 1/5, negative 1, and negative 5. So my points here would be negative 1, negative 1/5, 0, negative 1, and 1, negative 5. Okay, remember we said the domain is always negative infinity to infinity. And so let's graph these points and also talk about our asymptote here. So our asymptote, remember it's always your k value, and so I don't see a k value here. This would be plus 0. So my asymptote is y equals 0. So I'm going to plot that in orange at y equals 0. Right there. And then let's plot our points. So we have negative 1, negative 1/5, which if you were to plug that into your calculator, negative 1/5 is the same thing as negative 0.2. So that's just right around there. 0, negative 1, 1, negative 5, and that gives us an idea of the shape. Okay. And so I'm going to connect my dots, and I'm getting closer to the asymptote without touching it. Okay? Okay, our range. So think about, where is your graph here? If you're reading it from bottom to top, what's happening? So our graph exists underneath the asymptote. It's underneath, and so that means our bottom would be negative infinity, and our top would be our asymptote, which would be 0. Okay? Are we increasing or decreasing? Well, if I start at the left and I bring my pencil is going down. And so that means I am decreasing here. Okay? X-intercept, remember, is where y is 0. Well, our asymptote is at y equals 0, and so we never actually can find our x-intercept because we can never touch, we can't find our x-intercept because we never can touch the x-axis. And so here our x-intercept would be none because we don't have one, but we do have a y-intercept, and that is where x is equal to 0, and we can see that in our table right here, and if you didn't include that value in your table, you could look in your calculator and see that that point would be 0, -1, okay? Okay, now here we are at end behavior, and so remember, first spots here are -infinity and infinity, so now I'm trying to think, what is my graph doing? So as x gets more negative, as it goes towards -infinity, what is y doing? Okay, and this is where you're going to choose your range. Your range is going to go in one of these spots. So as x goes to -infinity, is y going to -infinity, or is it going towards the asymptote? And it's going towards the asymptote, and so it would be approaching 0. As x goes to +infinity, or as x gets bigger, well, that's where our graph shoots downwards and it goes towards -infinity, and so y goes towards -infinity there. Okay, end behavior is definitely trickier, and so as we do a few more examples, hopefully that will help you with these. I'm gonna not highlight my asymptote anymore. So there we go. Okay, let's try number 2. Okay, so here I see one transformation here. There's no negative out front, there's just this +3, which is our k value, and this is going to shift up 3. That is our transformation there. Okay, so I'm going to use my calculator to find my points, and I'm hitting just table, edit function. I want to clear and create my fraction. I'm going to put parentheses around it and put 1/2 raised to the x, get out of that exponent, +3, and I am just going to see what points I can find here. So I got some that get bigger as I get more negative, and then we have our fraction. So I'm just going to include one fraction. So here are my 3 points, -1, 0, and 1. X and y, -1, 0, and 1, at 5, 4, and 7/2. And you can include, by all means, any more that you would like to. That is what I'm going to put on mine. So, okay, so my 3 points are -1, 5, 0, 4, and 1, and 7/2. My domain, remember, is always -infinity to infinity. And if we even look back at this last problem, we can see that there's nothing stopping our graph from the left to the right. It's going to keep going to the left and keep going to the right in our range. So this is where, if you haven't already started graphing, that would be a good thing to do. And we have our asymptote at y equals 3. So I'm going to put that on here, y equals 3. And I'm going to plot my points. So I have -1, 5, 0, 4, 1, 7/2, which is right in the middle there. And if I were to just look at -2 is at 7, if you wanted to include that one, or maybe you did include that one. But there we go here, okay? Okay, now that we have our graph, we can kind of look at what is going on here. So our range, remember, bottom to top, what is the lowest part of our graph? And that would be our asymptote. So our range starts at 3 and it goes up forever. So then it would go up to infinity. So now looking at increasing or decreasing, if I start at the left, my pencil's going down, and so that means that I am decreasing here. My x-intercept, so that is where y is 0. Well, if I'm looking at my x-axis here, I never touch the x-axis. And so I can't have an x-intercept, meaning my x-intercept is none. And my y-intercept, well, we found that in our table, was 0, 4. Okay, now our end behavior. I'm going to show you a new trick of finding end behavior using your table if number 1 confused you slightly with finding end behavior. And so let's look at our calculator again. And I want you to look, okay, so look at your starting at 0. As x gets more negative, so scroll up on your table. What happens to your numbers? Do they get bigger, smaller? These get really big, right? So as x gets more negative, y goes to infinity. These numbers are going to keep getting bigger, okay? So as x gets more negative, y goes to infinity. Okay? As x gets more positive, so let me scroll down to my positive numbers, what happens to my y's? Well, they get closer and closer to 3, but they're not touching 3. They're going to get really close. They're above 3, but they're never touching it, right? It should say 3.00. It should just say 3. And remember, we even talked in class about if you see a point that just says 3, then it's a rounding number, right? So as x gets bigger, y gets closer to 3, but never touches it. And so that would be your end behavior there, okay? Okay, 2 more. Okay, so here I have my transformation up top, and this is my h value, right? And so remember, h is always opposite of what you think it is. That's what we did with quadratics last unit. And so this would be to the left 1, okay? And then if I go to graph this, if it focuses, come on, there we go. Table edit function, if I have 2 raised to the x plus 1, I want to keep that plus 1 up top here. I'm going to just go back and start back at 0 and see what's going on here. So, got some fractions here and I got some whole numbers, so I'm going to start at -2, so I include a fraction, and then I'm going to have -1 and 0 be my other points. You can include as many points as you would like on your graph. These notes just ask you to include 3, -2, -1, and 0 at 1/2, 1 and 2. So this is -2, 1/2, -1, 1, and 0, 2. So if I were to plot these, well, first off, my asymptote, nothing out front, so we have y equals 0 here. Okay. And then let's plot our points. We have -2, 1/2, -1, 1, and 0, 2. So we can tell we're getting closer to the asymptote on that side and getting bigger on this side. Okay, and remember, guys, domain is always -infinity to infinity. Think about your range here. Try this one on your own and think what your range would be from bottom to top. You are going from 0 to infinity and looking using your pencil. Are you getting bigger or smaller? You're getting bigger, and so this is an example of an increasing function. Okay. X-intercept, where it's crossing the x-axis, well, our x-axis is our asymptote, and so we can't ever touch the x-axis, and so this is none here. Oh no, there we go. And our y-intercept, we found that on our table at 0, 2, where x is 0. Okay, great, and then our end behavior. So this is where we are plugging in our domain for x, oops, and then we are looking at what y is doing. So I'm going to use our calculator again and look at, as we are getting more negative, what's happening. So as I get more negative, I am getting closer and closer to 0, but I'm never going to touch 0, right? And so that means as I get more negative, y approaches 0. Okay, and for getting more towards more positive as x gets bigger, my y's also get really big. And you can see that as you keep scrolling up. So y goes to infinity. Okay? Okay, guys, try number 4 on your own, and I will put the answers up here for you. So pause the video. Okay, so the transformations here are reflection over x-axis. Left 1 and down 2. Okay, 3 points on here. You have -3 raised to the x plus 1. Was it down 3? I can't remember now. Down 2. So and I'm going to start my function just at 0, just to keep it simple. And I'm going to pick some points here. So my points here are -2, -7 over, 3, -1, -3, and 0, -5. My domain is -infinity to infinity. My asymptote is y equals -2. Plot my points here. Something like that. The range is from -infinity to my asymptote at -2. I am decreasing. I have no X-intercept. My Y-intercept is at 0, -5. And lastly, my end behavior here is from -infinity to -2 and infinity to -infinity. Okay? Alright guys, hope this was helpful if you missed class or just needed to see these characteristics again. Have a good rest of your day and see